الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
Hello everyone, and welcome to another session in MENA Digital Days. And as you all know, this is week 43 of MENA Digital Days, and we are all excited to have you here. So in case this is the first session for you in MENA Digital Days, MENA Digital Days are a series of sessions happening every week, and they involve different topics, and you can see the recorded lectures on the YouTube channel, and also attend and see the schedule of all the next live sessions. Okay, and you also have the attendance certificate after every session, and you can go to this link, and we will share it with you in the chat right now with the code, and in order to fill the form and get your certificate after the end of this session. So this being said, I think we can start now with our session for today. So today we're going to have an intro to machine learning session. And before we start, let me introduce myself a bit. My name is Zena, and I'm a computer science student. I'm an Explore Machine Learning Facilitator with Crowdsourced by Google. And this is actually the presentation that I'm going to give you today is one of the beginner sessions in the curriculum set by Explore Machine Learning by Google. So in case we have any future sessions, we can also cover the more advanced sessions after this. I'm also a Google Developer Student Club Lead at the Lebanese American University. And you can also reach out to me on email or on my LinkedIn, and I'll be happy to connect with you and answer all your questions. Okay, so with that being said, let me go over the outline for today. So today we are first going to know more about machine learning and what is it exactly. We'll then see it's the difference between machine learning and the rule-based approach that we are usually used to in programming. We will also cover the different types of machine learning and have some practice questions on them so you can solidify the concepts. And we'll also go over TensorFlow and learn more about it. And I'll also, if we have time, go through a code example of training a model using TensorFlow. And I'll also share with you some resources that helped me when I first started, because I know that after this session, a lot of you would be interested in learning more about machine learning. So I'll be providing you some resources that can help you continue learning and get started in this field. And we'll also finally have a Q&A session in case you have any questions that I can help you with. Okay, so before we start, let's see this short video about machine learning in order to know more about it and have an intro.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognize a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organizing it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter.
Okay, so I hope that the past video gave us a small intro about machine learning, and as we can see, machine learning can be applied in lots of different industries. Like we can also, the simplest model can be classifying a cat and a dog, as we saw in the video. But in order to get a better understanding of what exactly is machine learning and actually try a machine learning ourselves right now, let's play a small game. So in case you have an Android phone, you can access this application called Crowdsource, and it's a Google application that can help you try the different machine learning models yourself. So I'll be pasting the link in the chat, and you can download it. Okay, so the link should be now in the chat. You can go to this link and download the application so we can try the game together. And in case you can't download it now or you don't have an Android phone, it's fine, because we'll be playing a prototype in the next slide, so you can also see how the application works. So I'll give you 2 minutes to download the application. And in these few minutes, if you have any questions, you can type them in the chat, and I'll be going over them right now while you are downloading the application. Okay, so I guess at 7:09 we can have the prototype played in case anyone hasn't been able to download the application. And if you already downloaded the application, you can go ahead and explore the different fields or tasks you can do in this application. And this is actually the Crowdsource app, in which you can try different machine learning applications, like classifying an image, which we will do now, and lots of other interesting games you can do with it. Okay, so I guess we can go ahead and see the prototype right now, in case you weren't able to try it out. So as you can see in the video, in this slide, you can see how a person is taking a picture of an object, and the model is telling them what exactly is this image. So all they have to do is just point the camera at this object and take a picture, and then the model will guess what this picture is about. And there are also lots of other tasks you can do with it, but right now we'll be focusing on the smart camera, or this game. So here you can see that it took a picture of something. It's typing some labels, and the model will directly tell the user what this object is. Okay, so I'll leave you to later explore it on your own, and also explore the other tasks in this application. And we will now discuss how does this exactly work. So it's interesting to take now a few minutes to think about how does this application work. So how is it exactly recognizing the objects, and how does it know what are these objects exactly? Because as we know, we can't really train using the rule-based approach to tell the model about all the objects that we have in the world. So for example, if we want to make it identify a bottle, without machine learning, we can't really show it all the different types of bottles that we can see in real world, because that's actually unfeasible, because we have lots of different shapes, colors, and lots of different types of bottles, so we can't really do that. So in this case, we need machine learning, and this is exactly how we'll see how exactly this works in the coming slides. But in order to understand this a little bit more, let's also play another small game, and this will be the last game we go along before getting started with the real material. So I also paste this link in the chat in case you want to try it after this. So this game is another machine learning game or application, and in this game, we actually need to draw something, and the application will tell us what we drew exactly. So here we'll try together this one. So let's draw. So here it's telling us to draw a cake. So let's see if we can draw something that the model can actually identify. So I'll try here to draw.
I see nose, or house, or bucket.
Okay, so
I know. It's cake.
It's identified the cake exactly, although my picture wasn't really perfectly drawing a cake, but I'm glad that it got it. Okay, so short funnister. I guess this will be a little bit hard for me to draw, but let me try. So
I see potato.
I'm drawing, and
or
you can
peanut,
see here that
or necklace, or balloon. I see stethoscope.
Okay, I don't.
Or bear, or sea turtle. Or kangaroo.
I don't think that I will be able to draw the monster,
or teddy bear,
because this is a little bit hard for me to draw. So,
sorry,
but you can see that
I couldn't guess it.
While it's, I'm not sure if you can hear it, but as I'm drawing it, it's telling me what exactly it's seeing as I'm drawing every line. So let's try the last one. It's moon. This should be really easy. I'll just draw it like this.
I see banana, or string bean.
Okay, let's try.
I see party hat, or boomerang.
Okay, I'm really not good at drawing.
I see circle.
Okay, it's seeing circle, and now.
Oh, I know. It's moon.
Okay, it's moon. It finally guessed it. Okay, so that's for now. If you are better than me in drawing, you can try it on your own and see if the game will know what are you drawing exactly. Okay, so these were the games for today. Let's now dive deeply into how are these exactly working. So we first saw the smart game application that identified our objects once we pointed the camera on. And then we saw how it actually identified what we are drawing. So whenever we are drawing something, it's directly identifying what are we drawing. And this is actually really interesting because as you all know, machine learning works on data, and the most important thing we have to train our model is data. And in order to tell you more how data works with machine learning, let me show you the kind of data that our Quickdraw application was trained on. So the Quickdraw application is the last game we played together, which is how our machine learning was able to guess the word that the picture that we were drawing. And the data that was used to train this model was actually a really interesting one, because let me show you over here. The data was actually collected from real people. So the people who designed this game went actually to real people, random people in the community, and told them to draw some objects. And as you can see here, this is the data that the application was using to train the model. And as you can see here, we have lots of different types of objects drawn in lots of different ways. And this is really important, as we will see in the next slides, to have data representative of a wide variety and different kinds of objects. Because as you can see here, if you can spot, for example, a carrot, you can see every time you see a carrot, you will see it drawn in a different way. And this is because different people are actually drawing the carrot. So if, for example, if we decided that one person will do all our data, and we told this person to draw a carrot 10 times, we will likely see the carrot drawn in the same, like approximately the exact same way all the 10 times. And this is actually inefficient when we want to use it to train a model, because we want our data to have lots of different shapes of carrots that people might draw. Because as you can see here, when we played the game, I might draw a carrot in a way, while other person might draw it in a different way. And when we put our model into production and users are actually using it, we want it to have been already trained on lots of varieties of different shapes of carrots to be able to identify it. And that's actually why why Google crowdsourced decided to build this data using different random people to draw these objects, so it can be representative of the real world data. So I hope this was able to help you more understand how exactly data works with machine learning, and we'll be covering it also in the coming slides. So as a final note, you can see here how our carrots here these are different shapes of carrots that was taken from the data. And as you can see here, every carrot was drawn differently, and you can't almost see any two identical carrots over here. And this is really important in the data that we use in machine learning. But however, we can see that all our carrots follow approximately the same patterns in terms that they have the same approximate shape, and they have those green leaves on top. So they follow the same approximate pattern. However, their exact shape differs. And the pattern that we just talked about is the main concept in how machine learning learn from data. And we'll see it in this slide. So we talked about machine learning, and we saw its different applications. We also played some games, and we talked about the data. But why exactly do we need machine learning when we, in fact, can just program the model as we normally write any code, whether it's in Python, Java, any other programming language? Why don't we just program it this way? And why do we need exactly machine learning? And this slide will help us understand why. So in case of a rule-based approach, for example, if we want to identify something, we can say, for example, if this object has a height of more than 10, you can do X. If its color is blue, you can do Y, and etc. However, when you think about it in terms of identifying a carrot, for example, can we actually program the machine to on all different types of carrots? For example, can we tell it exactly that the carrot, if you see something that has 10 leaves on top, it's a carrot? We cannot actually do that, because someone might draw a carrot with, for example, 12 different leaves, or the leaves might not have the same shape every time a person draws them, or in real life, actually. So we can't really follow a rule-based approach in some problem solving, because we can't simply put all the different rules or all the different features or cases we can see in the real world. And this is actually how machine learning can help us solve such problems. So in terms of machine learning, we can actually say that, okay, we want to build a model to identify a carrot, and we get different pictures of carrots, whether they are in real world, like real world pictures of carrots, or carrots that people drew. And we can train a model based on this data. So we can input the data into the model and train it on this data. And at the end, we can have a model that learned what are the patterns that it found in this data. For example, it can learn that carrots have approximately this shape. They have leaves on top. So whenever it sees an object that looks like this and it has this shape and it has leaves on top, it can directly identify it as a carrot. And this is, as you can see, this is really important. That saves a lot of time, and it's actually hundreds of times more efficient than actually programming the program using code that we might not actually be able to do using a rule-based approach. Okay, so after we went over these slides, let's recap a bit. We first show a small video about machine learning, and then we played two games, one of which is a smart game that can identify the objects. The other one is about drawing, where we drew pictures, and the app was able to identify what we drew exactly. We then saw the difference between rule-based approach and machine learning approach. So in order to solidify these concepts before moving on, let's answer some questions together. So I can show you the slide now, and you can answer on the chat, so you can see who gets the first answer, the first correct answer first. So okay, so you can see in this slide, you can answer on the chat, and I will be seeing the chat accordingly. So if you want to list song titles, if you want to sort or order the song titles based on alphabetical order, what exactly do we use? Do we use rule-based approach, or do we use machine learning? And think about the different cases, and if we really need machine learning here. So I'll be just waiting for answers on the chat. Okay, so we have Hassan. He said rule-based approach, and this is actually the correct answer. And in case you were thinking about machine learning, we don't really need machine learning here because we actually have limited sets of cases. We only have limited alphabets, and we don't really need machine learning here. So you can just program it using the rule-based approach. Okay, so let's go to the next question. If we want to rank web search results, what exactly do we use? Do we use rule-based approach or do we use machine learning? Okay, so I'll be seeing the answers on the chat. Okay, so I see some people answering rule-based and some people answering machine learning. And actually, no one can get a wrong answer here because the correct answer is both. And this is really interesting because we need both in solving such a problem because we have some some rules that we can follow to get the best matches in web search, and we also have machine learning. So, for example, if we want, if the user enters, for example, dinner recipes, we can actually get him or her the best matches based on what exactly did they enter in the search. So, for example, using the word dinner, we can get them directly some dinner recipes based on this word. And at the same time, we can also use machine learning here because based on their previous search histories, we can identify if this user, for example, is vegetarian. We can directly present to them vegetarian recipes. So in such a problem, we can use both the rule-based approach to get exact web search results from the search, for example, using exact words where websites mention these keywords. And we can also use machine learning to identify some patterns in their search results and present to them the best matches. Okay, so let's see this. If you want to predict the house prices based on location, what exactly do we use? Do we use rule-based approach or machine learning approach? Okay, so I see someone said machine learning in the chat, and this is actually the correct answer. Here, machine learning will especially be useful for us because we want to identify a pattern that we can then use to predict the next house that we see. We can't really use rule-based approach here because it will be inefficient for us to list all the different features and all the different cases, and we can't actually do that. So machine learning here can really help us identify a specific pattern at which the houses are being priced and predict the next price based on that. Okay, so finally, if you want to classify an object in a photo, do we use a rule-based approach or a machine learning approach? And this should be really easy because we did it in the game that we just played. So let's see. Yes, exactly. We use machine learning here to identify an object in a photo because as I said before, we can't really program something to know all the different types of objects that we might see in the real world. Okay, so before we move on to the next section, let's recap a bit the difference between rule-based approach and machine learning approach. So in case of rule-based approach, we have defined rules that we work based on, and we actually improve them based on algorithms and networks. However, in machine learning, we have data that we learn patterns from, and any improvement might come from actually having more additional data and having a more variety of objects in the data. As we saw in our pictures, we have different carrots drawn in different ways, and the more variety we have in the data, the better it is for the model at the end to identify objects that it has never seen before. So each has its benefits, and as we saw in the previous slides, based on the problem, we can decide which approach to go. Okay, so if we want to finally put machine learning in what is machine learning in specific words, we can say that machine learning take inputs, which are usually data, to make useful predictions and decisions about previously unseen pieces of data. So in other words, it takes data that we input, and this data can be like as varied as we can, so we can have the best results at the end. And using this data, the model will identify some patterns that it can follow to learn, and then predict the next decision based on unseen pieces of data. Okay, so machine learning systems might label or classify data. As we see, we saw how it can classify some objects that we input using our camera. It can also predict numerical values, as we have seen in an example about house prices. It can also cluster similar pieces of data together, and we will see this in the coming slides. It can also infer association patterns in data, and we're also going to see it in the next slides. And finally, we can create complex outputs in a really efficient way. Okay, so we just talked about some theory, we talked about machine learning, and let's see how exactly the different types of machine learning are and how can we actually implement them. So let's see this short video before we get started in the coming slides.
Suppose you have a great business idea and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has 3 phases: data, modeling, and production. In the data phase, you identify the input data that your machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make. Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data. For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase. Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex. Some models classify data. Other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses. Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn from the data. Along the way, there are quizzes to check knowledge and correct any misunderstandings. In the end, there's a final exam. When training the model, you split the data into 3 sets: training, validation, and test. The training set corresponds to lessons. Here, the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data to pick up on new patterns or trends. This training could come from new data sets or from interactions with users. The system needs monitoring. This means tracking system outages, errors, data processing volume and speed, and how successfully it predicts results. Machine learning systems also require maintenance. As with any production system, this means fixing bugs, adding features that didn't make it into version 1, and the like. Machine learning specific maintenance could include testing other models and settings to see if performance improves.
Okay, so we just saw a short video about how exactly data works inside the model. So we saw that data is really important, an important part in when building a model, and this is because we want to split it into parts. We want the training part, testing part, and sometimes the validation part, so we can train the model and then test it on data that it has never seen before and see if it's actually a good model or we need to refine it a bit. So in order to summarize the process exactly, let's go over this slide. So we first start by focusing on the user and we see what the user exactly wants and what's the problem that we need to solve. And we then go over the objective. We need to define what exactly our model should do at the end in order to do the data based on that. And we also need to test the model based on that. So we then go over the collecting the data phase, and this is a really important and usually a long part of the process because we want to find data that's representative of our real world data, and it also needs to be processed. So we can't directly use data as it is. We need to first do some data pre-processing first to prepare the data to actually be used in the model. We will then train and test the model. As I said, we need to have a training data and testing data. Training data to train the model on this data, and then we need to test the model using the testing data in order to actually test it on something that it has never seen before and see how it's actually performing. And after this, we need to finally see our model and see how it predicts and evaluate it. And as you can see, we actually have arrows coming out of the predict and evaluate, which is the final stage of our model. And this is because this is a really iterative process. We can't really end this process. It has to go over from the beginning every time it reaches the end. And this is because we need to keep on modifying and improving the model. Because as we know in the real world, we keep on having new data. We keep on having changes in the data that we have. So we need to have our model up to date always. And that's actually why we need to go back to the beginning once we reach the end. Okay, so this is a really short video that shows you a little bit about a different part of machine learning, and this is the privacy in machine learning. So after this video, we can continue about the different types of machine learning, but this is interesting to see.
Machine learning systems require lots of data to make successful predictions. What happens when that data is sensitive, such as people's names, credit card numbers, or medical histories? Sometimes, sensitive data is needed to train a model so it can make accurate predictions. But at the same time, this data must be carefully protected. This is the challenge of machine learning privacy. Let's look at an example. Suppose you create a machine learning model to diagnose illnesses based on a person's symptoms. Someone who reports a stuffy nose and a cough might receive the diagnosis the common cold, whereas someone else with the same symptoms plus a high fever might be diagnosed with the flu. Plenty of other factors might influence the diagnosis too. Does the patient have a medical history of similar symptoms? Did she recently travel to another country or spend time on a farm with livestock? Are other family members or roommates sick at the same time? To train this model, you could feed it information about thousands of people and their symptoms, medical records, and demographic information. This data includes plenty of personal information that needs to be kept private. In addition, the data sets involved might contain other private information not directly relevant to medical diagnosis, such as patient contact information or the credit card numbers used to pay healthcare providers. What steps should you take to protect user privacy? Step 1 is to gather and select only the data that your ML system needs to achieve its goal. The less private data you have in the first place, the less you need to protect. This might seem like common sense, but it takes effort. It's easier to copy a whole database than to spend hours removing the parts that you don't need. Step 2 is to identify any data in your datasets that may be sensitive. For example, people's names, addresses, telephone numbers, email addresses, government ID numbers, and other personally identifiable information, or PII, should be kept private. Another type of private information is user-generated content, such as email messages, YouTube videos, blog posts, and any other content created by known individuals. Be sure to work with your product counsel to determine which types of information are considered private and how to handle them. You also need to make sure you have permission to use the data and whether the data has other privacy restrictions. Be sure to work with your product counsel here as well. Step 3 is to protect the private data. You can do this by controlling access to the data and your ML model, or by altering the data so it's not recognizable anymore, or both. Privacy is a critical concern in machine learning. When you maintain privacy, you build trust with users and protect your company's interests.
Okay, so we saw here a different part of machine learning, which is about privacy, and we saw how we need to really take into consideration privacy whenever we deal with data, because we need to protect some private data that we need to remove sometimes from our data, or to deal with it differently. So before we move on, imagine, for example, that we are building a model that can predict the next word that the user is typing on the keyboard. So for example, if the user is typing a sentence, based on what the words, what we have currently, like what the user input, we can predict what the coming word will be. And we actually see this into real world application. When we type on the keyboard, we can see the suggestions that we have on top of the keyboard. So let's say, for example, that we didn't take privacy into consideration when building this model, and we used all the data that we have, which includes passwords that we got from users. So imagine that the user is inputting or writing a sentence, and then the next suggested word would be a password for another user. So imagine how disastrous this situation will be. And this is why machine learning privacy is a really important part when dealing with data. Okay, so let's continue about machine learning and its different types, and what exactly can machine learning do. So we saw how machine learning is actually a combination of 3 different things. It's a combination of algorithms, or the machine learning algorithms that we actually use. It's a combination of big data, and it's also a combination of technology. So all of these together make machine learning. And to dive deeper now into machine learning, we have 2 different types of machine learning. We have supervised machine learning and unsupervised machine learning. So in supervised machine learning, we are dealing with labeled data. So we have data, and we have that what every data or every picture or an object that we have its labels. So for example, if we are training the model on cats and dogs, we have all the pictures that represent cats labeled as cats, and we have all the pictures that represent dogs labeled as dogs. And then we use this data with their labels in order to help our machine learn the patterns from them. So this is supervised machine learning, because we are supervising it, or we are giving it the labels for the data. However, we also have unsupervised machine learning, and this is actually when the data is unlabeled. So we just input data of different objects without labeling them. And the machine learning will actually automatically, or by itself, identify different patterns in the data and group them together. So it can identify that all the pictures that follow a certain pattern are from this group, and all the others that follow a different pattern are from other group, and so on. And we will see examples of these in the coming slides. So the first example of supervised machine learning, where we have actually labels on data, is classification. And this is the kind of application that we saw when we were identifying some objects using the pictures, or the game that we played. Or for example, when we want to build a model that can identify lions or cats or dogs. And in this case, we actually just have data, and the machine learning will at the end predict a specific category of the new input that it will take. So we will first build a model that can predict the difference between cats and dogs, for example. And then the end model that we have after testing it and after training it, whenever we input a new picture of a cat, it can automatically classify it as a cat. And similarly, for example, when we input a picture of a dog, it can correctly classify it as a dog. And so on, based on different problems that we are trying to solve and different data that we use. And you also actually can see it using the crowdsource application that I previously showed you. You can download the app in case you haven't already, and you can try the smart camera, you can try the image label verification in order to see it in action. Okay, so the second type of supervised machine learning is regression. And in regression, we actually do it whenever we have data that's in a specific pattern or that can be drawn on a graph using a line. So for example, when we want to predict the duration of our trip from spot A to spot B, we can use regression. And then after plotting the data, we can draw a best fit line that most accurately goes through the data points at the same with the least errors that can help us predict the next label or the next data input. Next, we have unsupervised machine learning, and the first example of it is clustering. When we don't really have labels on data, we just input different pictures, and the machine learning will group the different pictures based on different patterns that it sees. For example, if we have different numbers from 0 to 9, and then we put them into a machine learning model and train it on this data, it can actually group all, for example, the 9s together, all the 2s together, all the 3s together. And we sometimes need to have sub-clusters inside specific clusters. For example, we can see in the picture that sometimes a 2 and a 7 might look alike. So in this case, we have a sub-cluster inside this bigger cluster to correctly split the 2s and 7s from each other. So next we have sequence prediction, and this is what I previously talked about, where we input the words on keyboard, and then the machine learning will directly tell us what the next word is. And you can also see it in action in case you want to try it using the crowdsource app. Okay, so let's play a similar game to what we played before in order to solidify the concepts more. So in case we have a recommending next word in an Android SMS app based on the words typed so far. So what exactly is the approach that we will follow? Is it classification, clustering, regression, sequence prediction, or style transfer? So you can type the answers in the chat, and I'll be seeing who types the first correct answer. Okay, so someone said sequence prediction, and it is the correct answer. Okay, so let's see labeling email as spam or not spam. What do you think is the best approach to go with this? Okay, someone said classification, and it is the correct answer. Okay, finally, the identifying trends amongst a group of people who have bought a new music release. So this is a little bit harder than what we have seen before, but it's actually something that we have also seen in the previous slides. So in case you have a group of people and we want to classify them based on different what they have bought regarding a new music release, for example. Okay, I see classification, regression. Okay, someone said clustering, and this is the first correct answer. Yes, exactly, it's clustering. And let's think about it a bit, because we have people who have bought a new music release, and we actually want to cluster them based on that. So people following a similar pattern will be clustered together, and so on. Okay, so we have famous landmarks in a photo, and we want to identify these landmarks. So what exactly do we use? Okay, so I see classification, and it is the correct answer. Okay, so finally, the last example we'll go through is suggesting spelling corrections. So this can be a little bit tricky, so think about it before you type in the chat. If we want to identify spelling corrections, what exactly do we use? Okay, so I see style transfer. No, this is not a style transfer example. I see classification, sequence prediction, regression. No one said the correct answer so far. You can actually know what the correct answer is because we have already seen all the other different answers. So let me see until someone says it in the chat. Regression is not regression. We don't really have a specific point that we can plot in the graph and then draw a specific line through them. So this is why it's not really regression. And it's not classification. Okay, I see clustering, and this is actually the correct answer. Here it's clustering because you can see whenever you cluster data and you have a wrong word that's typed incorrectly, it can actually go nearest to the most correct cluster. So we have different points, and then we have a word that's typed incorrectly. This incorrect word will go closest to the cluster to which it has the correct answers in, and that's why it's a clustering example. Okay, so let's review a bit. We talked about what is machine learning. We talked machine learning versus rule-based approach, and we said where can we use each. We also have covered idea to implementation, where we covered different types of machine learning, and we also saw the different types, which are classification, clustering, regression, and sequence prediction. So finally, let's go over something really important whenever we build a machine learning model, and this is actually loss. So after we have a fully trained model and we want to test it, it's really important to see which model gives us the lowest loss, because we want to have a model that's as accurate as possible before putting it into production or in real world. And here you can see different graphs of different models that we can get whenever we build a model or we train a model. And we can see that in the third model, we got the lowest amount of loss, and we actually have the best line that's drawn that reduces the losses the most. And this is actually we'll go with that model and not with the other models, because this model will give us the lowest loss and thus the most accurate one. Okay, so finally we can go over TensorFlow. So TensorFlow is an open source machine learning platform, and it has lots of libraries that can help us build and train a model without actually really worrying about the computations behind it. So for example, in the loss, if you want to evaluate a model after we built it using TensorFlow, we can actually just see which libraries we can test the model on, or which machine learning algorithms we can use, and directly use them without really worrying about what is the math behind them or memorizing the formulas. So this is why TensorFlow is really important, and it really helps. And it also has some data sets that you can get started with in case you are a beginner. You can directly use the data sets that they have to get started and train and practice on this data. So I'll be giving you some I'll be giving you the link. So we were supposed to go over this code together, but we don't really have time. So hopefully, if we have any upcoming sessions, we can go through it, or you can also go through it on your own. It has lots of different. It has lots of different explanations on every code that you have, so you can actually understand everything after you learn the concepts from the resources that I'll be telling you about in the coming slides. So after you learn the concepts, you can go to the link that I pasted in the chat. And in this link, you can find documentation for TensorFlow. And this documentation is really important after you have the concepts in your hand to actually start practicing and build some new models yourself. Okay, so I believe that lots of you want to get started with machine learning on their own, but they don't really know how to get started. So these actually are resources that I personally used. So this is a personal recommendation from me. You can, of course, have different learning patterns, but what I personally found helpful was a book called Hands-on Machine Learning with Scikit-learn and TensorFlow. And you can see the screen, you can see the name on the screen with the author name. And this is actually a book that really helped me to learn the concepts. So after you learn the concepts from this book and you practice some models on your own, and you can also follow the models that this book suggests, you can go to TensorFlow and start learning TensorFlow and practicing using it. And I also pasted the link for that documentation in the chat. And then you can go to Kaggle, where you can see lots of different data sets that you can and competitions that you can participate in. And Kaggle has also lots of different data that you can use to just identify a problem and solve. So it's really important also, and really useful for you. And in case you finally decided to take on the TensorFlow Developer Certificate, you can take this course, Deep Learning.ai TensorFlow Developer Professional Certificate on Coursera, and it really helps preparing for this certificate. But this is actually like at a later stage of your journey, after you got the concepts and practiced a lot using Kaggle and TensorFlow. And of course, the best suggestion is more practice. The more practice, the better you get in machine learning. And finally, I just wanted to go over Crowdsource by Google. So Crowdsource is a really useful and interactive application that some of you might have already downloaded it by now. So this is a Google application that allows you to help contribute to data sets by answering some questions and while also playing games. So it's really important to help build diverse training data for machine learning. You can answer simple questions, earn badges, and level up. You can also connect with contributors around the world and improve Google products for everyone. So that was everything. And don't forget to fill the form with the code to get your certificate. And thank you for attending today. And in case you have any questions, I will leave the last 9 minutes to answer your questions. So in case you have any questions, please type them in the chat, and I'll be going over them now and answer any questions that you have. And thank you again for attending this session, and hope to see you in other upcoming sessions and in other MENA Digital Days sessions. Okay, so link can't work for me. What link exactly? Is it the TensorFlow link? So let me type the link again. Okay, so I pasted the link again in case it did not work for you. And in case this link also doesn't work for you, you can just go to Google and type TensorFlow and you can get the documentation. But actually, yeah, TensorFlow will be helpful after you get the concepts. So you can use the book that I suggested or just learn through different resources on your own and then start practicing with TensorFlow. Oh, link to certificate. Okay, so let me paste the link. Okay, so I pasted the link to the certificate, and you can use the code. Let me type the code. Okay, so it's already in the chat. You have the form and the code. And someone asked about the recording. This video will be directly saved in MENA Digital or GDG MENA YouTube channel. So you can just after the end of this session, you can just play it again, and the recording will be saved there. Okay, so how to get dataset CPPS, Cyber Physical Production Systems. So you have to actually search for your data and make sure that it does not have any copyrights and you can actually use it to train your model. And this is what we actually previously talked about in terms of machine learning privacy. But actually you can find lots of data. For example, on Kaggle, you can find lots of data. Okay, so in case you have no more questions, I guess we can end the session here. Thank you again for joining us today, and we look forward to seeing you in the next sessions in MENA Digital Days, and I hope that you have enjoyed and benefited from this session.